This is my ColecoVision computer, which is based on a ColecoVision console. And in the ColecoVision console, they had a Texas Instrument display IC. And in the ColecoVision console, it would have been originally a NTSC version of the integrated circuit. This one is the PAL version, which is a TMS9929. The NTSC version of this particular chip, which is equivalent, is a TMS9919. And they also produced another one, which is a TMS9918, which you see here. And this does the same as the other chips, except this one has a composite output actually on the chip, whereas these ones have output of luminance and chroma, and you have to make your own composite circuit to actually combine those two and generate a composite signal. At the time, there probably wasn't very many display ICs on the market, and this one is a really neat chip because I can actually swap these ICs without having to change any circuitry, and I can change my computer from a PAL version of the computer into an NTSC version of the computer. And on the ColecoVision, some of the games came in cartridges which were actually dedicated to PAL or dedicated to NTSC. You could play most of the NTSC cartridges on the PAL system, but some of them require the 60 Hertz timing, which you get on NTSC to actually play correctly, whereas PAL has 50 Hertz frame timing. So I'm actually making my computer to be a PAL version of the computer. However, I want to make a couple of boards which are also NTSC versions. I want to actually prove that the NTSC chip could actually run in my circuit, so that if I ever release this circuit, then I can actually say that the NTSC chip will just plug in here and it will work as the PAL chip does. So what I'm going to do in this video, I'm going to power up this computer with the PAL version, show it playing a game, then I'll swap over the chips to the NTSC version without making any adjustments to the circuit. I may just slightly tweak the frame alignment on the actual display, because the clock might just need a couple of hertz difference, but that can be done with a variable capacitor, and just prove that both NTSC and PAL chips can be interchanged without actually having to change any of the circuitry. Okay, so if I power up the computer and just hit the reset, so there's Frogger in the background. So this is on the PAL version. Now I haven't combined the color, the chroma signal with the luminance on the PAL, so you only get a black and white image, but because this chip is the composite version of the chip, you'll actually see color when I plug this one in. And actually, if I'd had the 9919, which is the direct equivalent of this chip, where you have to combine the chroma and luma, you'd see the same kind of picture, the black and white picture as you see now. So I'll just start the game just to show that it can actually run. So there's it running in the PAL version on in black and white. And now I should be able to just change over the chips. I'll be careful how I do this. I don't want to break any of these chips. I think someone recently seemed to have cornered the market in them, and whereas there used to be some Chinese shops, Chinese places on eBay which had a fair amount of these display ICs, and they all have had their stock bought up, and now the price of the chips seems to be twice as much from different eBay sellers. So that's the PAL version taken out, and I won't try not to. I will actually do my development with the with this version of the chip from this point onwards, because until I get the actual chroma merged with the luma, because now I can actually get color output. Okay, I think that's right. So there it is, and I just have to, like I say, adjust the display a couple of hertz. There's a couple of hertz difference between the two chips, and there it is with the color on the display. So now I can play Frogger in color on the NTSC version of the chip. Now, what you will have heard is a slight difference in the pace of the audio. So if you play this back again go back to this chip, and you'll hear that the actual audio plays slightly slower because it's playing at 50 Hertz. Whereas on the NTSC version, it will be playing at 60 Hertz, so it plays slightly higher pitch and slightly faster. But I just wanted to show that actually you can just swap these chips interchangeably and not have to change the circuit. I mean, have a little capacitor to adjust the frequency slightly. So to go over the differences between the two sets of chips. So on the left I've got NTSC chip with the composite video output, and on the right I've got the NTSC and PAL chips with the colour and luma outputs. So all the green pins which have been highlighted in green, they're all functionally the same pins and don't have to worry about anything to do with those pins. But the differences are, start with pin 38. On the composite video output chip, it's got a CPU clock of 3.58 MHz coming out of it. So 3.58 MHz is the NTSC color burst frequency, and because this is an output, you can actually use this to drive your CPU, so you don't need two crystals in your computer circuit. You can use the output of this, and that simplifies the circuit a bit. But on the two chips, NTSC and PAL, which have the composite luma and the color outputs, this is the red difference output. So because they're both outputs, there's not really a conflict in the signals, but if you put the CPU clock out on the red color difference output, then it's going to probably make all kinds of funny colors on your video display. So if you put this in a circuit, it's probably best to put either a jumper in here, or a physical jumper, or a solder bridge jumper, so that you just can disconnect this signal when you place it into the circuit, which expects the red color difference output. Then the next one down is the Grom clock. Now apparently this doesn't get used on many circuits, but although it does get used in the BBC Bridge Companion, I noticed that because they use that as the CPU source, and the CPU source comes out on one of these chips which has the 4.17 kilohertz coming out of it. So that's the difference here, is that on the composite video chip you've got the color burst signal frequency coming out of the Grom clock, 3.858 megahertz, and on the Grom clock on the other two chips it's 417 kilohertz. So that could cause a problem if you're using the Grom clock, but not if you're not using the Grom clock. Then the composite video, although I've put these both in green, so the composite video is color and luminance and sync signals, so horizontal and vertical syncs, whereas the Y is just the luminance and the sync signals for horizontal and vertical synchronization. So on this pin, if you just take this and place it into a composite video input on a monitor, you'll get a black and white image, whereas on the composite video output on the other chip you'll get the full color composite video. So the difference obviously being on the chips on the right, you need to combine the luminance with the chroma, so you need a circuit to do that. And then this is the real difference. The most concern is the pin 35. It's an input on the composite video chip because you can bring in a second composite video source from this into this external VDP pin, and you can mix it with the output of the actual chip, and you can combine the two into a single image. So you can like overlay, you can have the external video as a background to your normal video, and some MSX computers did that, but generally it's not really used. This is, like I say, this is an input, whereas on the other chip it's an output, which is the blue difference video. So again, if you want to swap over these chips interchangeably, then you probably want a solder bridge or a physical jumper so that you can disconnect the external video input from the blue difference output.